Hi everyone. In today's video, I will take up another question from Captain Subramaniam's Ship Stability Series Part 2. This is from the section of Trim, Type A questions, Exercise 22, question number 15. Alright, so here I have written the question exactly how it is written in the book. It's an unsolved question. So the length between perpendicular is given as 124 meters, MCTC 180, TPC 27, HF is 2.5 meters aft, draft forward is 5.8, aft is 6.9 meters. You have to find out how many tons of seawater must be run into the forepeak tank, which is located at HG 58 meters forward, in order to reduce the draft aft to 6.7 meters. And then you have to state the final draft forward. You have not been asked the final draft aft because it is given to you already that the final draft aft should be at 6.7 meters. Alright, and currently the aft draft is 6.9 meters. So let's draw a diagram before we start with the question here. So what I'll do is this vessel is trimmed by stern, so I'll just give it a slight trim by stern here, and then here. Alright, so the forward draft currently is 5.8 meters. The aft draft is 6.9 meters. This is midship. We call it H. The total length of the vessel is given as 124 meters. So total length of the vessel is 124 meters. So from midship to aft will be half of LBP, which is 62 meters. This is 62 meters as well. Right? What else is given? So HF is 2.5 meters aft. So that means the center of flotation is 2.5 meters aft of the midship. This is where center of flotation is. So if the total distance from aft perpendicular to midship is 62 meters and center of flotation is 2.5 meters aft of midship, so from aft perpendicular to center of flotation, which is called AF, is equal to 62 minus 2.5, which is equal to, how much is it? 59.5 meters. Alright, now let's see the situation we are in. We are at a draft of 6.9 meters. We have to run seawater into the forepeak tank. That means the forward part of the tank. So let's assume it's somewhere here. This is the forepeak tank, and this is at HG 58 meters forward. So HG, that means from H to the center of gravity of the tank, is 58 meters. Right, but this is not the distance we are interested in. When we are talking about changing trims, we are interested in the distance from the center of flotation, from F to the forepeak tank. So here we can see this distance will be, and this is called the distance D. This is nothing but 2.5 plus 58, which is equal to 60.5 meters. That is the distance we are interested in. Alright, so do not get confused or do not get distracted by the distance of HG. HG means from center of midship to center of gravity of the tank. G is the center of gravity of the tank. But when it comes to trim, we are more interested with distances concerning the center of flotation, because that is what affects the trim. Alright, so that is also something I have figured out now, and let's understand the question. So the aft draft right now is 6.9 meters and we have to run water into it. So we have to fill, it's like loading cargo into the forepeak tank, and we have to reduce the aft draft to 6.7 meters. Right, so that means from aft draft, let's write down aft draft current is 6.9 meters. Aft draft required is 6.70 meters. So that means change in the aft draft required is 6.9 minus 6.7 is 0.20 meters. Right? Can we say that? correct? So from 6.9 we have to make it to 6.7. So change in the aft draft required is 0.20 meters, which is also equal to 0.20 multiplied by 100, which is equal to 20 centimeters. I want it in centimeters for calculations. Now remember, this is the aft draft required, right? So that means that change in the aft draft required. All right, so we also have to find out how much weight will this add to the vessel. So how much weight do we have to add to the four-peak tank? So when we add weight to the four-peak tank, there will be some kind of a mean sinkage. Mean sinkage overall, which will also affect the aft draft. All right, after filling four-peak tank, and I don't know the weight yet, so I will call it W divided by TPC. So this W divided by TPC is given to me as 27. This is going to be the overall mean sinkage of the vessel, correct? So not only do I need to lighten the vessel, but I also need to be aware that this is going to cause an overall sinkage of the vessel, both aft and forward. All right, so that means that the change in the trim aft that is required is not only 20 centimeters. I don't only have to lighten the vessel by 20 centimeters, I also have to lighten the vessel by this amount here, the mean sinkage. So this vessel, when I load the water here, when I load the water in the four-peak tank, the aft vessel will, of course, the overall sinkage will happen. So firstly I have to reduce 6.9 to, I have to make it 6.9 to 6.7, right? But when I take on the vessel, or rather when I take on the water, the vessel is going to sink further. So that means I have to now reduce it further by the mean sinkage amount. So not only do I have to reduce it from 6.9 to 6.7, I also have to be aware that from 6.9 it may become 7 meters when I am taking on water because of the overall sinkage. So I have to take that also into account. I just cannot think of reducing it from 6.9 to 6.7. I also have to take into account this amount, which is the mean sinkage amount. So the total change in the aft trim required will be not only 20 centimeters but also this amount here, right? But this is the total change in the aft trim that will be required. So I have to lift the aft draft by this amount. Now change in the trim aft also equals the formula AF, that is from center of flotation to aft perpendicular, divided by LBP multiplied by overall change in the trim. But overall change in the trim is written as W, that is the weight loaded, multiplied by the distance D that I've already explained to you. This distance 60.5 meters D, divided by MCTC. So what I'll do is I will take this formula and replace it here. So change in the aft draft required equals AF by LBP, and instead of writing TC I will write W by D by MCTC. Alright, and then we also know that change in the aft draft required is this here, and this is also equal to this here. So taking this equation and this equation, I will equate the two equations. So I'll get rid of TA in both the equations and I will equate the two equations with each other. So what will I do is I will write 20 plus W by 27, which is also equal to TA, which is equal to AF by LVP multiplied by W by D by MCTC. I will equate these two equations together, right? So when I equate these two equations, let's fill in the numbers first. So I know some of the numbers here, so I will fill up these numbers. So I know AF is 59.5. I showed you how. LBP is given to me is 124 meters. W is something I don't know. Distance I know is 60.5 meters. I showed you how again. And MCTC is given to me as 180. right? Now I have to solve this equation. So I can solve the left hand side first. So this becomes 27 multiplied by 20, which is equal to nothing but 540 plus W. Oh, sorry about that. So I'm now getting excited, so I'm writing faster than I'm thinking, which is not good. So here, right, and then this one you can simplify it over here itself. So just do 59.5 multiplied by 60.5 divided by 124 divided by 180. W you can't do much about, so this becomes 0.1613 if you want W. Then take this here, right? So 27 times, so this becomes 540 plus W, and this becomes 27 4.355 W, and then this goes here, right? So 4.355 W minus 1 W, let's call it 1 W equals 540. So this is minus 1. So 3.355 W equals 540. So W equals 540 divided by 3.355. The answer better be right, otherwise I am in trouble. Why? So we have 540 divided by 3.355 is 160.96, or we can call it 160.96, or I think in your books it's 161 liters. So let's call this 161 liters of water, right? That will be pumped, or 161 tons of water rather, not liters. I'm calling it liters, I don't know, I have no idea, maybe I am calling the answer from the book. So I will call it 161 tons actually of water. So 161 tons of water is to be filled in to make sure that the aft draft remains at 6.7 meters. But the question is also asking us what is going to be the draft forward. So now we know that the draft aft will be 6.7 meters. If I load 161 tons of water into the forepeak tank, which is located at a distance of 60.5 meters. So that means the trim. So if the aft draft TA is equal to, we have already established, right? Aft draft equals 20 centimeters plus W by 27. So that means whatever change in the trim forward, whatever the overall change in the trim will be, so let's what is the overall change in the trim is W by D divided by MCTC. So now I know W, so I can put 161 multiplied by 60.5 divided by MCTC is 180. So again, see, I'm excited, I'm trying to go for 180. The answer you will get is overall change in the trim will be 0.5411. Is that right? Just let me check again. 161 multiplied by 60.5. I don't want to give you guys any wrong answers. Is equal to, yeah. So the answer you will get is of course 54.11, but this is centimeters. So just divide it by 100 and convert it into 0.5411 meters. So this is meters. Just to clarify it. All right. So because this moment to change trim by 1 centimeter, so the answer you get is in centimeters. So just divide it by 100 to get it into meters, because that's how you have to convert it. Right. Now this is equal to TC. But remember, the change in the trim aft required was from 6.9 to 6.7 meters. That was the change in the required. So that was 0.20 that we have established. Right. So TF, that is a change in the trim forward, will be, change in the trim forward will be 0.5411, which is TC, minus 0.20, TC minus TA, which is equal to nothing but 0.3411 meters. All right. So forward draft is, how much is the forward draft? I have to go back again, isn't it? Forward draft is 5.8. Right, forward draft is 5.800 meters. TF is 0.3411. Now because you are loading in the 4 peak tank, you have to add the forward draft will increase by how much? 6 point. Is it right? 6.1411 meter. That is the answer. 6.1411 meter. That is the answer. I hope. I don't know. 5 point. Sorry. Let me just check. 5.8 plus 0.3411. 6.141. Yeah, that's right. So that is the final draft forward. All right. So I have established this hopefully correctly. Match your answers from the back of the book. And I hope you understood how I went about solving this question. If not, then put it in the comment section. I will try to address it. Sometimes, I lose track of questions which are so long, but I hopefully have done my job here. So guys, good luck with your studies, and let me know if there were any questions, any doubts, any points that you didn't understand, and I'll see you soon with my next